everybody, JeremyBlum here with episode 13 of my Arduino tutorial series sponsored by Element 14. This week we're going to be talking about liquid crystal displays, or LCDs as they're more commonly known. We'll be using a 16:2 character display. The specific display that I'm using today was supplied to me to review by Element 14. It's a little bit bigger and draws more power than most LCD displays and has 2 extra pins for a heater on it. All the schematics and stuff associated with this episode are showing you how to do it with a more standard 16:2 display. Just keep in mind while I'm hooking mine up that some of the pins are kind of in a different order, but all the labels are the same, so it should make sense if you look at the schematics for how to wire one up. So liquid crystal displays are great because they allow you to untether your project from your computer. Something we've been doing with a lot of the projects in the past is sending data back over serial to the computer so you can then process it and do stuff with it. But if you have a display built right into your device, then you no longer need to have the computer hooked up. You can bring your device with you and have it display meaningful data to you. And that's really, really useful. So let's talk a little bit about how our LCD will interface with the Arduino, and then we'll hook one up, and by the end of this episode you'll have a nice little project with an LCD, a temperature sensor, and you'll be able to read Celsius and Fahrenheit room temperatures. Alright, let's get started. Alright, let's talk about getting our LCD display hooked up. All LCDs 16:2 character displays basically have the same interface. They're all going to be 16 pins, pin 1 here, pin 16 here, with a number of logic lines and then power and ground and an LED hookup and whatnot. The only other component that you're going to need is a 10 to 20K potentiometer. I'm going to use a 10K breadboard mount potentiometer, and we'll use that to control the contrast of the display. So some LCDs will put these in a different order than I'm showing here. This is a pretty common configuration. The LCD I'm using today actually puts them in a different order and adds 2 more pins for a heater to help it operate in colder temperatures, but I'm just not going to use those. I don't need to hook them up. But this is a very common configuration. So let's talk about how we're going to hook this up. First off, the LED backlighting, we're just going to give it 5 volts on LED+. We're also going to need 5 volts for the logic input to the display, and our potentiometer is going to be hooked across 5 volts and ground, and then into the display to control contrast, so we're going to need another 5 volts up there. So those are all of our 5 volt signals. On ground, there's going to have to be the other end of the LED, of course, so that we can actually light it up. And you can actually control the backlight with the Arduino if you want to turn it on and off, but I'm just going to hook it right up to 5 volts. We're going to need to ground the logic for the actual display, and then ground the other end of the potentiometer. The next thing here is the RW logic pin. So that means you can choose whether you want to read or write to the display. Ordinarily, we have no reason to read from an LCD display, we only want to write data to it. So we can actually tie that to ground instead of being able, we don't need to control it with by wasting a pin on the Arduino, so we can just tie it right to ground and not have to worry about it. That means we're setting it to always write to the LCD. Next thing is the V0 pin. So the V0 pin allows us to set the contrast of the display, and that's what our potentiometer is for. So you'll hook the middle pin of the potentiometer up to V0 like that. It's pretty straightforward. And then all of our other pins we're going to use for sending data. So we have the RS pin that will go to one I/O pin on the Arduino. The E or enable pin will go to another pin on the Arduino. Now there's 8 data pins here, 0 through 7. What's interesting is that you can actually just use 4 of them and still transmit all the information you need, and then you don't have to waste 10 total connections to your Arduino just to drive this LCD. So we are actually not going to hook up D0, 1, 2, or 3. We're just going to hook up D7, D6, D5, and D4. So in total, we're just going to have 1, 2, 3, 4, 5, 6 connections going to the Arduino for control. These guys won't get hooked up. We have our LED backlight hooked up, logic hooked up for the LCD, contrast hooked up for the potentiometer, and RW is just hooked right to ground. So we're ready to go. Let's get this wired up and programmed, and we can start showing some stuff on our screen. Once you've got your circuit wired up, it should look a little bit something like this. Now keep in mind that I have a high power backlight in this one, so I couldn't power it off of USB only. I had to plug it into the wall also. You won't have to do that. I also had to add a resistive voltage divider here to get to 6 volts for the LED backlight. You can just hook your LED backlight line right into 5 volts from the Arduino. So keep that in mind while you're looking at this. But once you turn it on, you should get something like this on the display. And if you don't, make sure that you twiddle the contrast knob here, because that will allow you to adjust the brightness of the image. And you can see as I turn the knob, it adjusts how dark the image is. So you want it kind of somewhere in the middle, and you'll see once we have text on it, that's about a level where you want it. So just that somewhere good. Your backlight should be on if you're assuming your backlight is plugged into 5 volts, and you can see that mine most definitely is. And if I unplug it, you can see what it looks like with it off, much darker. And I plug it back in, and it's nice and bright again. So that's basically it. The data lines are hooked up. You can, if you download the schematic from my blog, it'll show you exactly which one I wired them into, or in a second we'll do it in the program, and you'll be able to see which ones I hooked it into. I hooked it into 2 through 7 in order, starting with the control pins and then adding the data pins. So let's go ahead and get this programmed so we can get something a little bit more interesting on that display. Okay, it's time to write a simple example that will test our LCD setup. First thing you should do is make sure you credit the creators of the library on the top of your source code file, because we're open source here, and it's always nice to give credit where credit is due, because these guys made an awesome Liquid Crystal library. So be sure to give them a shout in your source files. Here I've defined the pin hookups that I'm going to be using, and these are the ones I just showed you on the breadboard. RS is on pin 2, Enable is on pin 3, and then pins 4 through 7 on the Arduino correspond to data pins 4 through 7 on the LCD for convenience. First thing we'll need to do is include the Liquid Crystal library, which is what we'll use to interface with the LCD. So that's called, simply enough, liquidcrystal.h. So you should include that. And then once you've included it, you can make an object with it. So we'll call our object LCD. And the parameters for LCD are just the pins that you're hooked up to in the order that I've already listed them. So it's 2, 3, 4, 5, 6, 7. Don't forget your semicolons. Okay, next thing here that I've already written out because it's relatively long are some custom characters. So if you take a look at the sample display that I've already put together, you can see a nice little progress bar going across the screen. To accomplish that, I had to make custom characters that fill up one pixel column at a time on each of the 16 characters so that we can animate them across. And that's what we'll do right now. So each of these is a byte array that's 5 by 7 because that's the number of pixels in each of the 16 little boxes that go across the first and second rows. And the ones and zeros here correspond literally to which pixel is on. So we can make this byte array. The B specifies that these are binary values, and you can see the kind of progress bar action happening here as the ones move across. And then we can use those characters later on to make a little progress bar animation. So when we go down to the setup now, the first thing we want to do is begin our LCD interface, just like we begin the serial interface, for example. Do lcd.begin, lowercase b, 16, 2, and that's indicating that there are 16 columns and 2 rows. First thing I'm going to do, it puts the cursor by default at the beginning. I'm going to print out Jeremy's display by doing lcd.print, and lcd.print will just print any standard characters, numbers, etc. Jeremy's apostrophe s display, and this happens to already be 16 characters, so I know that I'm good to go. If it's not, you can add trailing spaces, or you can just make it less than 16 characters and we'll take up the whole line. That's totally fine. The next thing we need to do is actually initialize the byte arrays that we made up here as characters that we can send to the display. So you can only do a set number of these. This is less than the amount. I don't know the exact amount off the top of my head. It's in the documentation for the Liquid Crystal library. But we can do lcd.create char, and you give it an incrementing number, and then whatever the byte array was that you named it. So I'll do that for each of the byte arrays that I defined above. All set. Okay, so those are our chars. Now all we have to do in the loop is basically move across the bottom row and fill these in line by line and then reset them and do it over again. And that'll be in a big giant loop down here. So the first thing we need to do is, I don't actually have to do this the first time around, but after we've made the progress bar, it's going to be important to move the cursor back to the beginning so that we start writing stuff at the beginning of the second row again. So to move the cursor back to the beginning, I'm going to do lcd.setCursor 0, 1. And so the first thing here, the 0, is specifying that we're using the first column. So these are 0 index, so 0 is the first column. And the 1 here indicates that we're using the second row. And that's a little confusing, but if you basically just add 1 to it, each of them, it should make a little bit more sense. The next thing we'll do is clear the line because we've just finished our progress bar and we want to start again. So we'll do lcd.print, and I'm just going to print out 16 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, all good. And now we're just going to do 2 nested for loops that handle the outer nested for loop will go through each of the 16 characters, and then the inner nested for loop in each one will print out the custom characters that are percentages of each set that we defined before, and print those out in order so that we get a nice progress bar effect. So we'll make our outer for loop first, int I equals 0, I less than 16, I plus plus, so this is going 0 through 15 in terms of the indexes that we want to work with. And remember, we need to be starting at 0 because these are 0 indexed for the cursor. So that will have a for loop, and then inside that for loop, we'll have another for loop. So at each point in the outside for loop, so at each position on the screen, it will make a new custom character. So we'll do for int j, make sure you choose different variable here. That's very important so they don't interfere with each other. J less than 5, J plus plus. So this is going 0 through 4. In other words, the guys that I defined up here, that's actually a mistake. Those guys should be numbered correctly. There we go. So this will go through each of those 5 guys up there. So we'll make that for loop. So at each position, the first thing we need to do is set our cursor there so that we know that that's where we want to write. lcd.setCursor I, 1. So the I is because we're at that particular position on the bottom row, and the 1 is because we are on the bottom row. Then we're going to use lcd.write, which is different from lcd.print, in that we can use it to output a custom character. So we can write j. So by saying, like, for example, the first time through this, we'll write our 0, which is custom char 0, which is our 20% line. So that will work out nicely. And then, of course, we're going to need a little delay here so that this doesn't happen faster than we can even see it. So let's just put a 1/10 of a second delay. That should be enough, probably. Okay, let's see how that works. All right, and we can see that it uploads onto the Arduino very nicely, and that we have a very nice progress bar effect going across. It printed my name on the first line, and then on the bottom line, you can see it goes through, and instead of just doing it block by block, it actually does it pixel by pixel, which adds a very nice effect there. Okay, cool. So now let's make this a bit more complicated and get it a temperature sensor on there and a little button to interface with, and we'll have this giving us our room temperature in Celsius and Fahrenheit, and we'll actually have some interactivity out of it. All right, here are my plans for our revisions to our system to add a temperature sensor and a nice little readout. We already have these green lines hooked up for the LCD. These are the data lines and the control lines over here. We already have our pot hooked up. What we're going to add is a TC74 I2C temperature sensor. We have used this in previous tutorial number 7, where we learned about I2C communication. So you should already have this part, hopefully. And so this just communicates over the I2C bus to the Arduino, and the I2C bus is multiplexed on analog ins 4 and 5. So we'll plug that in just like I show in the schematic here, making sure that we have our 10K pull-up resistors that go from those communication lines up to our 5-volt bus over here. So this will sense the room in degrees Celsius and report us that value. And then we can print out the temperature here in degrees Celsius on the LCD display in real time. But seeing as how I live in America and we still use this stupid thing that's called imperial units, it's nice to know the temperature in Fahrenheit as well. So I've added a push button here, and we'll use the debouncing software that we learned about in episode 2 to hook our push button up to Arduino's digital input 8 and use that to switch between Celsius and Fahrenheit modes. And I've intentionally positioned the push button here right next to the screen because we'll add a little indicator here on the second row that says mode, and it will point to the button so that you know you can press the button to change the mode, and that'll be a nice little setup. And then don't forget, for that, we have another 10K, this time acting as a pull down resistor. So by default, the button is pulled through this 10K to ground, except when you push the button down, when it shorts, goes to 5 volts, and then sends that value to the Arduino where we debounce it and use it to control our system. So let's get this programmed, and then we'll get it wired up and ready to roll. So now we've got our circuit design, and I've already gone ahead and put those changes onto the breadboard that I'm using, just adding an I2C temperature sensor, some pull-ups for it, and a button is basically all you need. So that's already set up, just like I showed you in the schematic. And now it's literally a matter of copying and pasting code from episodes 2 and 7. So if you haven't watched episodes 2 and 7, go watch that now. It'll make all of this make a lot more sense because I'm not going to redo stuff that we've already done. So in episode 2, we talked about bouncing, and 7, we talked about I2C interfaces. So first thing we're going to do here, I'll just walk you through some of the changes I've made, and then we have to finish up the program together. So I've included wire.h, which is the I2C library for communicating with I2C chips, like our temperature sensor, and we know from the data sheet that the ID of our temperature sensor is 72. So that's all set up. I got rid of our progress bar custom characters, and I actually made a new custom character called degree because we need a little degree symbol for our Celsius and Fahrenheit. And you can see where the ones are. It makes a nice little degree circle up there that we can use. And now this is literally copy and pasted from the debouncing code in tutorial 2. I'm just setting the input for the for what pin the switch is connected to. It's pin 8 in this case, and I'm setting button states, which are booleans, so true or false, to low initially for both of them, and then I'm also just going to initially say that we're going to default to Celsius, and then pushing the button will change it to Fahrenheit, and then changes back, etc. In the setup, I've specified the switch pin as an input. Began the wire library. Again, this is all straight from tutorial 7. This is the same as before. I changed this to say room temperature instead of Jeremy's display, just like before as well. I now move the cursor to the position 11.1, so this is the second row, position number 11 on there. So the reason I did that is, remember, I placed the button immediately to the right of the second row. So this gives us just enough room to write mode with a little arrow next to it. So that will be pointing directly at the button. So you know to press the button to change between temperature modes. So this is kind of a neat little feature there. And then just like before, we have to create our custom chars. In this case, we only have 1 as opposed to the 5 that we had last time. And it's called degree because that's what I called the byte array up here. So the only thing that we have left to do now is to do our loop. The debounce function is already written. This is, again, the debounce function straight from episode 2. You don't have to rewrite anything. And this just takes in the last button state and spits out the current button state after debouncing it. I've already added in the lines that grab the temperature and put it into Celsius and Fahrenheit from the I2C temperature sensor because this, too, is copied directly from tutorial 7. Isn't it nice to have code that you already have to work with? It makes everything a lot easier. So the only thing that we have to do now is basically grab the information about the button state and then throw in what we want to have on the display. So we've got our temperatures here. Let's write some button switch code. The first thing we're going to do is get the current state of the button using our debouncing function, and this too is exactly what we had already done in tutorial 2. So remember, I already defined current button up here as well as last button. So we're debouncing the last button to get the current button. Okay, so if the last button was low, and remember, double ampersand indicates a logical and. The current button is high, so that means that someone is currently like holding down the button. They just pushed the button, and this has already been debounced. So we can now say, okay, that's the case. Someone has just pushed the button. So if Celsius is currently true, which we can make an if statement in here. So this is shorthand for saying if Celsius is true. You could also write equals equals true, but you don't have to. Actually, that would be lowercase. You can do that, but you can just write something as simple as if Celsius. So if Celsius is true, then we're going to set it equal to false, which means we'll be working in Fahrenheit mode. Otherwise, we're going to set it to true. That does not need that. Okay. And now, importantly, we have to erase the old characters so we can write the new temperature over them. So we're going to do lcd.setCursor, and we're just going to write these at the first position on the second row. .setCursor 0, 1, just like we did in the previous example, and lcd.print. We're going to clear those, making sure, however, not to make this so long that we clear our mode setup here. So instead of making this 16 long, this is 5 characters up here. So we need to make this actually 11 long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And you actually can make it shorter than that because we're not going to use all those spaces, but I'll just make it the full size. Doesn't really matter. And now we're going to set last button equals to current button. Because each time we've gone through the loop, we're now done with current button, and that can be the next time through the loop. It will be what is then the last button. Okay, so that's done. Now we actually have to just print it to the screen, and that's pretty simple. We just look at whether it's Fahrenheit or Celsius and print the corresponding thing. So we'll do lcd.setCursor to 0, 1 at the beginning again. And then if Celsius, we'll use the same shorthand we used before. Then we'll do lcd.print. We will print out the variable. Then we will do lcd.write. Remember, that allows us to use our special character. So we'll print out the degree sign, which was number ID 0. And then we'll do lcd.print again, and we'll print the letter C to go after the degree sign. Perfect. And now we'll do the exact same thing for Fahrenheit. So otherwise, it's Fahrenheit. lcd.print the Fahrenheit temperature. Then lcd.write our degree sign, and lcd.print our Fahrenheit. Oh, and this should actually be text as well. That's important because it's not a variable. A variable would not have quotes around it. And close off our brackets here, and that should do it. Okay, so make sure you have your electronics hooked up as shown in the schematics, and then let's see how this works. Oops. Gotta have a space there. Alright, and so the program's on there, and it seems to be working quite nicely. We can see the current room temperature is hovering between 27 and 28 degrees Celsius, which is quite warm. I have my air conditioning turned off so that you can actually hear me talking. So I'm basically torturing myself for you guys, so I hope you're enjoying this. And if I tap the button, it goes into Fahrenheit mode, and you can see it's about 81 or 82 degrees Fahrenheit in here. And sure enough, you can go back and forth with relative ease. We have our nice mode thing that doesn't disappear or anything when we're switching between modes. And yeah, it works quite nicely. And you can see over here is our I2C temperature sensor. and everything else is wired up just like it was before. So very nice, and you can make just about anything you want with this, so go have fun and do some cool projects with an LCD. Thanks for watching this episode of my Arduino tutorial series. I hope you guys enjoyed it. I have a review of the LCD readout that I used today on my blog. You should go check it out if you like the readout that I was using in the demo today. It's a little bit bigger and more expensive than most LCD displays, but it has a really nice contrast and a very bright backlight, and so if that's something you want, it's also very large. This might be the display for you. Otherwise, go check out adafruit.com. That's the link I'm going to put in the parts list for this video. They have a more standard 16:2 LCD display. It's smaller, cheaper, and it comes with the header and the contrast knob for adjusting it. So you should go check that out. Relatively soon, I'm going to be putting out a review for a shield for the Arduino for attaching an LCD display. It's made by Wicked Devices. They sent me one to review, so that will come out pretty soon, and that'll allow you to put the LCD right on the Arduino so you can get something more compact than a breadboard. So look forward to that. And yeah, that's about it. So if you have any questions, comments, etc., feel free to post them on this video, on my blog, on element14.com. And I also now have a Facebook fan page, which is a little embarrassing, but I do. People kept asking for it, so I made one. So you can now like me on Facebook if that's your thing. And I'll try to update that with assorted information, particularly about when these tutorials are coming out and stuff. And I also have a Google+, so you can go add me on Google+, if you now have that. And the links for both of those are on the sidebar on my blog, so you can go check that out if you want. Otherwise, I will see you guys very soon. Thanks again for watching. Thanks to Element14 for helping me to sponsor this video series. They were kind enough to provide a lot of the materials that I'll be using to create these tutorials. Feel free to go visit their website at element14.com. Check out their community, which is a great place to talk to people about electronics, the Arduino, and basically anything else engineering related. And they also have a store where you can buy a lot of the parts that we'll be using in these videos.